Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will demonstrate how to certify a multimode fiber optic link using a micro-OWL optical power meter and a dual OWL series multimode light source. There are 5 main steps in the process of certifying any fiber optic link. These steps are gathering link information and accessories, checking equipment and accessories for proper operation, entering link information into the certification tester if available, and setting an optical reference, also called zeroing, taking insertion loss measurements and storing test results, and then downloading stored test results to a PC and printing a certification test report. Before beginning any fiber test, the user must gather the necessary link information and accessories required to complete the test. Link information is used to help determine how much loss is acceptable for the fiber under test, otherwise known as a link budget. Optical loss measurements are compared to the link budget to determine if the fiber is good or not, which is the same as saying pass or fail. There are 5 key parameters that apply to any fiber optic test. First is the fiber type, which will be either single mode or multimode. In the case of multimode, this could be either 62.5 or 50 micron. Next is fiber length. It is important to know how much fiber is in the link under test in order to determine how much loss is acceptable for that particular length of fiber. Some OWL testers can be used to measure the end-to-end length of the fiber automatically, including the FiberOwl 4 bolt optical power meter. Otherwise, the user can use jacket markings, installation documents, or other length measurement methods such as OTDR. For best results, avoid estimating the fiber length whenever possible. Third is number of connections. A connection is the point where 2 fiber connectors mate together, such as in a patch panel, wall plate, or mating sleeve. Fourth is the number of splices, which can be either fusion or mechanical. For the purpose of calculating a link budget, most cabling standards do not distinguish between fusion and mechanical splices. Lastly, the user must determine what wavelengths they will test at. For multimode, this is 850 and/or 1300 nanometers, and for single mode, this is 1310 and/or 1550 nanometers. When using a micro-OWL or fiber-OWL optical power meter, these parameters can be entered directly into the device to calculate the link budget. However, if the link budget needs to be calculated manually, this is done simply by adding together the fiber loss, connection loss, and splice loss. Fiber loss is given in dB per kilometer and varies based on the fiber type and wavelength. To calculate fiber loss, multiply the fiber length in kilometers by the fiber loss. Connection loss is the number of connections multiplied by the dB loss per connection. Splice loss is the number of splices multiplied by the dB loss per splice. Most users will follow the fiber, connection, and splice loss specified in cabling standards, such as the TIA 568. It is also helpful to determine the connector type used in the link under test, which will help determine the right reference cable configuration to use. For accessories, it is highly recommended to keep at least 3 patch cables on hand, since there are 3 reference methods: 1 jumper, 2 jumper, and 3 jumper. Mating sleeves may also be required for some link configurations. Refer to OWL's video on reference methods for more information. Finally, if testing multimode fiber, the launch cable attached to the light source will also need to be wrapped around a mandrel according to cabling standard specifications. Refer to OWL's video on mandrels for more information. Once we've gathered our link information, and obviously we've gathered our accessories here as well, our power meter, our light source, and our multimode cable wrapped around a mandrel. Now we can begin to check our equipment to make sure it's working properly before we begin our tests. So what we need to do here is connect our reference cable to our test equipment. So what we need to do first, in this case, we're going to be testing at 2 wavelengths. That's why I have a duplex cable wrapped around a mandrel here. Now, the reason there is a duplex cable is that instead of having 2 mandrels and 2 reference cables, it's easier to manage 1 mandrel with a duplex cable. So what I'm going to do is I'm going to connect both of our reference cables to our light source ports here quickly. Okay. Now what we do is we find our 850 nanometer port on this side, and we plug that into the power meter here. Okay, so now we're connected. What we need to do now is power on our test equipment. So this is easily done on the dual owl by pressing the power button. You can see that 850 nanometers is initially lit by default. And then on the micro owl, we simply press the on button. Now you'll see a couple screens here as far as booting up the micro owl. Eventually you'll come up to an operating mode screen here with 3 different options: simple meter, certify link, and tech support. For checking our equipment first, we want to use simple meter. It's easiest to do it that way. So now that we have simple meter highlighted, we can simply press F2 to select. Okay, now you can see that we have a reading of minus 20.29 for 850 nanometers. Now remember, our target value is minus 20 dBm. This is where our multimode sources get calibrated at, and the calibration occurs through a mandrel wrapped cable. So you can see that we're very close to minus 20. Now if we're reaching minus 21, then we want to start considering replacing the patch cable. But for now, this is a good reading. So now we know that our 850 nanometer reference cable is okay. What we do is we disconnect it from the power meter, and then we plug the 1300 port in. Okay, now you can see that it says under here. This is because there's no light coming in from the 1300 port. We haven't changed the wavelength yet. What under means is that there is no light coming in. It's complete darkness to the power meter. So first thing we do is we press the wavelength button on the dual owl, and you can see that it switches over to 1300 nanometers. We also have to change the wavelength on the micro owl. You see it says 850 nanometers here. So we need to switch it to 1300. We can do that by pressing F3. Okay, now you can see that we have a reading of minus 20.12 here. Again, this is a good patch cable. What we've done here is verified that our patch cables and our test equipment are in proper operation for our measurement. What we need to do next is to set up the equipment with the link information that we gathered earlier, and to zero out our testers. Now that we've verified that our patch cables and our equipment is in proper operation, now it is time to enter the link information we gathered earlier and to zero out the equipment. Now, the initial part of this process, first entering the link information, will not really require the light source. So what I'm going to do is I'm going to set that off to the side for now. And what I'm going to do is I'm going to zoom in on the micro owl's screen so we can see it a little better here. Okay, now if you remember earlier, we were in simple meter for doing the equipment check process. Simple meter will not let us set up the link information. We need to be in certify link mode for that. So in order to enter certify link mode, we need to press the done key to return back to the operating mode screen. Press F1 to highlight certify link, and then press F2 to select. At the start menu, we need to press the number 1 for Link Wizard. Now, Link Wizard is simply the process by which you're going to be entering your link information. So we press the number 1, and we come up to a screen that says Select Link. Now, as far as the micro owl is concerned, the word link means a group of fibers that have the same characteristics. So same fiber type, same fiber length, same number of connections, and same number of splices. So the basic configuration of that group of fibers is going to be the same. Now, in the micro owl, there are 8 different links that you can store. So 8 different sets of configurations. But what we're going to do here is we're going to select fiber link 1, and that's the fiber link number where we're going to store our link configuration. So since it's already highlighted, we press F2 to select. and we see we have a link name screen here. This is a way of naming this particular link parameter. You can name this whatever you want. It could be based on the job you're doing or the company you're testing for. But for our purpose today, we're going to just take the default value, FiberLink1. Once you're done entering the link name, press Done. Now, you'll see the next screen here is entering the date. Now, this is important. This is the date that will appear on the certification report. It's kind of nice to be able to enter the date manually here so that, for example, if you're going to be doing a test tomorrow, you can put tomorrow's date in, but set the meter up today. Now, in order to enter the date, we simply need to press F1 and backspace over the whole date here, and then we enter the date in the format shown here. So today is April, and then if you need to enter a special character, you use the 0 key, and you can use dashes in the place of slashes here, and then we type 10 for the 10th, another dash, and then the year is 2013. So now that we've entered the date, we simply press the Done key. Now we come up to a screen where we have a list of the fiber standards that are programmed into the micro-owl. Now, as you can see, there are the highlighted standard is called the TIA-568B. Now, this is probably one of the most popular standards that anyone will be using for certification, at least in the United States. There are quite a few different cabling standards as well. As you can see here, there's an ISO standard, which is common in Europe. There are some Ethernet standards, and there are also some user-definable standards, as you can see up here, for advanced users who want to develop their own TIA-type link budget. But for our purpose today, we're just going to select the TIA-568B. So we're going to press F2 to select, and then we see that we have a screen where it's asking us to enter the fiber type. Now, because we're doing a multimode test today, we have to choose one of the multimode options. And let's assume that we're testing 62.5 micron multimode fiber. So we highlight that option and press F2 to select. Now, one of the pieces of information that we need to gather is the length of the fiber under test. Now, the length is important because this tells us how much loss we are allowed to have based on the cabling standard for the fiber itself. So let's assume that we have 325 feet of fiber. Now, as you can see, it says meters here. We're not entering in feet. Let's say we don't know how many meters we have. We have 325 feet. Well, you can simply press the F2 button to toggle between meters and feet. As you can see here, as I press F2, the units change. Okay, so in order to enter in feet, simply make sure that it says feet here, and then we type our number 325. Okay, once we're done entering the feet, we press Done. And then we have enter number of connections or patch panels in the link under test. Now, a connection is simply, like it says there, a patch panel, but it can also be a wall plate or just another adapter or a mating sleeve, that sort of thing. Normally, you'll have 2 patch panels in the link under test. Maybe you'll have a rack in 2 separate closets that you're testing between. You do have to include those patch panels in your test. So what we're going to do is we're going to assume that you have 2 connections, 2 patch panels, and then we're going to press Done. The next screen is enter number of splices in the link under test. Now, most of the time, multimode fibers will not have a splice anywhere in between. However, there's a new type of connector style out there called Unicam, or more generally a no polish, no epoxy type connector that uses mechanical splice technology to make the termination. So inside the ferrule of that Unicam type connector is a little mechanical splice. 2 fiber stubs are being pushed together. So in all fairness, those are considered splices. So let's say you are using a no polish, no epoxy connector on both sides, and we'll press the number 2 here to say that we've got one on each side of the link. So once we've done entering the number 2 here, we press done, and we come up with a review screen. Now it says what standard we've used, what our length is, and as you can see, the micro has converted it back to meters. Fiber optics needs to be in a metric system. 2 connections, 2 splices, 62.5 micron multimode fiber, and then we are asked to confirm this setup. If it's not correct, we press no. Otherwise, we press F1 for yes. Okay, now we come up to the part of the process where we're setting the reference or zeroing out the equipment. This is where the light source comes back into play. So I'm going to zoom out a little bit here. And we'll bring the dual owl into play. So as you can see, we still have the 1300 nanometer option selected here. And you can see 1300 is over here. So as long as we're connected with 1300, we might as well set a reference for that wavelength. Now, we were assuming that we're testing 2 wavelengths today. So that's why we're going to test 2 wavelengths. Now, you don't have to. The standard does not require you to test at both wavelengths, but a lot of customers feel that it's a good idea to test both wavelengths just to be thorough. So what we're going to do is we're going to first set the reference for 1300, and as you can see down here at the bottom of the display, there's 3 options: wave, set, and done. Wave simply toggles the wavelength between 850 and 1300. Set starts a set reference procedure for the selected wavelength, and then done is when you're completely done setting the references. So we're going to press F2 to begin the set reference procedure for 1300. As you can see, it says connect 1300 source. What we need to do here is make sure that we have our 1300 nanometer indicator LED lit, and that we have the 1300 nanometer patch cable connected over here. Once we've verified that, then we can press F1 for done. Okay. Now it's going to confirm. Are you sure you want to set this reference? So we are connected incorrectly, so we're just going to press F1 for yes. And it says saving, and now you can see that it has our reference level here, minus 20.12 dBm. Remember that our target value is around minus 20. So we're good here. And remember, we don't want to be any worse than minus 21. Now, since we want to test both wavelengths, we need to set a reference for 850 as well. What this means is that we need to first connect the 850 nanometer reference cable. So that's what we're going to do here. To the power meter. And it's already connected to the light source via the duplex cable. But what we need to do first is switch the wavelength over to the 850 nanometer port by pressing the lambda button. Now, as you can see, it flashes briefly and then goes solid here. And so now we're set to 850. On the power meter, we press F1 to highlight the 850 with the asterisk here. And then we just, again, press the set button. We confirm that we've connected, confirm that we want to set the reference, save the reference, and again you see minus 20.28. That is a good reference for 850 nanometers. Now, we have set the reference for both wavelengths, but it's a good idea to check the equipment, make sure that it is actually zeroed out when you're taking readings. So we press F3 for done, since we've completed setting references. And then we say yes, we want to begin taking readings. And we see on the screen here a dB reading. Okay. Now, we see that it says fail here, but what we need to make sure is that we're on the right wavelength. You see it says 1300 here, but 850 over here. So let's switch the wavelength with the F3 button. Okay. Now we see that we're at 0.00 dB. What this means is that we confirm that we have zeroed out at the 850 nanometer wavelength. It's a good idea to check the 1300 as well. So what we're going to do is we're going to connect the 1300 nanometer cable back in, switch the wavelength on both units, and you can see 0.20. There may have been something, well, maybe maybe sometimes that the cable is not pushed in all the way, or maybe something got moved in the reference cable here. But anyway, so this is still a good reading. You're about 0.2 of a dB off a little bit, but you're still passing here. So this is acceptable. Once we've verified that we've zeroed our equipment, now we can begin taking readings. But what I'd like to do quickly here is to cover some of the aspects on the screen here. Now, as you can see, there's a big number here. That's your loss reading. Loss is always given in dB. As you can see here, this is a pass reading. It means we haven't had enough loss to exceed our link budget. Over on the right-hand side here are 74 degrees. That's the temperature. This percentage here is the battery life of the power meter. You can see that we have fiber link 1. That's our link name. And then new name here. What this means is that we haven't stored any data yet. So we haven't assigned a name to these fibers. The wavelength here, 1300, and then the three function options at the bottom of the screen here. So once we've verified that we've zeroed our equipment, now it's time to take readings. Now that we've entered our link information and zeroed our equipment, it's time to take readings. Now, to do that, we need to take the light source to one end of the link and the power meter to another end of the link. However, before we do that, I want to cover a couple key issues regarding once you've set a reference with the light source. The first thing is you do not want to disconnect either of these connections once you've set a reference. If you happen to disconnect these cables, they will have to be re-zeroed. The second thing is to not let the mandrel wrap come undone at all. This will also change your reference. If that happens, then you will also have to go through and set your references again. Okay, now that we've covered that, we can take the light source with its reference cables to one end of the link, and we'll do that here. Okay, and then we take the power meter to the other end of the link. Now we would have checked a third patch cable during the equipment check process that we would use for the power meter. So we have our third patch cable here, and we will connect that into the detector port on the power meter here. Okay, so now each tester is on its own side of the link, and what we can do now is start taking readings. We connect into our link. Now, for convenience sake, I'm going to use this little box here. It's a simulated fiber link. So what we have to do is pretend here that let's say side B is one side of the link and side A is the other side of the link. Okay, so I'm going to demonstrate that here. So the light source is on side B, power meter is on side A. Now, the first thing we need to do is connect into port number 1. Okay, so that's usually where you start. You start at port number 1. So we're going to connect in on both sides. Okay, remember that we're going to be using the 850 nanometer reference cable here. So we need to locate that and connect in. And as you can see, we have a reading show up on the screen. If you can see that here, it says 1.73 or negative 1.73. That means that you have 1.73 dB of loss, but you're still passing by almost 3/4 of a dB. As you can see, there's a pass reading. That's good. So what we need to do is we need to store the reading here. So we press the F2 button to begin the store process. And for the first reading that you store for this particular link, it's going to ask you to change this fiber label. Now this fiber label is simply a prefix for the port number that you're testing at that point. The micro-owl will automatically append a fiber number at the end of this prefix. So this could be used to further name the fiber link that you're testing. For our purpose today, I'm just going to leave it as the default value here. So once you're done entering your label, you press done, and you see a review of the information on the screen. So you have fiber link 1, that's your link name. You have your fiber ID, fiber:1. your fiber type, and your wavelength, and your loss, and your pass-fail result. Okay, if you're satisfied with this result, we simply press the F3 button for save. Okay, now that we've saved fiber number 1, as you can see, the microhull has already changed the number to 2. What it's doing is prompting you to hook into fiber number 2. Okay, now, as far as a helpful tip, when storing readings with the dual owl and micro owl, the easiest way is to store all the readings at one wavelength first, and then switch the wavelength one time, and then store all 6 readings at the next wavelength. So what I'm going to do here is I'm going to demonstrate that. I'm going to kind of speed up the process here, and I'm just going to store all 6 readings, and then I'll show you switching to 1300 shortly. Okay, so we've stored all of our readings at 850 nanometers for all 6 fibers. But since we're testing at 1300 as well, what we're going to do is we're going to test using the 1300 nanometer reference cable on a light source. So we can disconnect the 850 nanometer reference cable. We're done using that one. And we grab the 1300 nanometer reference cable here and plug into port number 1 again. Okay, and also with the micro owl's reference cable, plug it into port 1 as well. Okay, now you can see that there's no light coming in. That's because we are not using this 850 nanometer reference wavelength anymore. What we need to do is press the wavelength button on both units to set to 1300. So on the power or on the light source, it's this lambda button. And then again on the power, now I can see you're taking a reading here, but it's wrong because you have 850 nanometers set. You need to make sure that you remember to switch this to 1300. Now, one thing to note here, notice that your fiber number went back to fiber number 1. The micro owl conveniently sets this back to 1 because you want your 850 nanometer reading to show up with your 1300 nanometer reading for port number 1 for this link. So it automatically starts over at 1 again. Okay, so now again I'm going to speed this process up and we're going to store all 6 readings. And finally we store a reading for fiber number 6. Now, as you can see, we have passed at all of our readings. Both 850 and 1300 nanometers are passing. So we're satisfied with those results. We can disconnect our testers from the link under test. As such here. And then we can take our micro owl to our PC to download our test results. Once data has been stored in the optical power meter, test results can be downloaded to a PC to produce the certification test report. First, install the USB driver and owl reporter software from the supplied CD or a USB flash drive. Connect the power meter to the PC using the supplied USB cable. And then power on the power meter. Then start the owl reporter program. The program shortcut can be found in the Start menu. When the software has started, the screen will initially say no data loaded as shown here. Download the test results to the PC by pressing either the download menu option or the download button. While downloading, the status bar will say searching for owl device. Once the test results have successfully been downloaded, the data will appear in the owl reporter screen. The test results can be viewed in 2 different formats. This view is called Circuit Detail View. It shows detailed information about a single fiber run. The other view is called Circuit Summary View. Circuit Summary View shows basic information about a group of related fiber runs. Certain buttons become active when summary view is selected. Pass-fail, overhead, which shows how close the test is to its fail point, or optical loss. Toggle between summary and detail view by pressing this arrow button. Test results can be printed from the File menu or Printer button. The printout will show test results based on the currently selected view. The reports are formatted to look like the OWL Reporter screen. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos, or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.